375 at the origin we are taking here x naught is equal to 3.5, x is equal to 3.75, x means x naught by h is equal to 3.75 minus 3.5 by 0.5. So 3.75 means what is the finding value here? 3.5 is the minimum, the 3.5 x naught is equal to 3.5. The result of the t again 0.25 by 0.5 is equal to 0.5 I am taking here. Then immediately since 0 greater than 1, since it is 0 greater than equal to 1, we can apply the Gauss interpolation formula. Y naught by u is equal to y naught plus u delta y naught plus u into u minus 1 cube delta square y minus 1 u plus 1 u minus 1 3 factorial by del cube y minus 1 u plus 1 u minus 1 u minus 2 అంటే u plus 1 u minus 1 u minus 2 del 4 ఇక్కడ 4 factorial వస్తే del 4 వస్తుంది. So we are taking here u into u minus 1 u minus del 4 y minus 2 u plus 2 plus 1 u minus 1 u minus 5 factorial అంటే del 5. So ఇక్కడ ఇవ్వండి u plus 2 కి u minus 2 u plus 1 ఇక్కడ u plus 1 u plus 2 u plus 1 u into u minus 1 u minus 2 ఇక్కడ only you have to take u plus 1 into u minus 1. So you have to take u plus 2 also you have to take here that one. Now we are consider the default table with the given data we are taking here. X equal to 2.5, 3.3, 0.0, 3.5, 4, 4.5. 5 I am taking here. Minus 2, minus 1, 0, 1, 2, 3. Y is equal to 24.145, 22.043, 20.225. Why? Because I am taking 3.5 as 0. So 20.2.5 I am taking here. So that immediately 1 is equal to 18.664. 18.664, 17.262, 16.407. The values are assembled, but we are taking this is the center of 2 get cancelled. So but I am taking the 3.5 is 0. Now I am taking minus 1, minus 2. So 0, 1, 2. Substitute 2.5 minus 3.5 by 0.5. 3.0 to 3.5. 4, 3.5 minus 3.5, 0. 4 minus 3.5. 4.5 minus 3.5. 5 minus 3.5. That is the values I am writing here. So we get about it 24.145. So I am taking 22.043 minus 24.1.5 minus 2.012. 25 into 23 is the minus 1.818. So 18 log into 20 this is the minus 1.51. 17 local 18 this is the minus 1.382. 16 local 17 this is the minus 1.9. So minus 1 into the plus out the minus 1 plus 2 into 0.284. The minus 1 is plus of the 0.5, 0.8 plus 0.237. Because the 0 loss without the hold this amount 0 hold this amount. Minus 1 plus 1.5 0.19. Minus 1 plus 1.3 to 1.67. So 0.20 minus 0.24. So 237 to the minus 0.2047. 0.19 is 0.237 this is 0.38. 0.16 on the 0.19 this is 0.03. This is plus out in the plus 0.009. This is plus out in the 0.038 in the 0.6. In any case this is a minus 0.003. So substituting the relevant values from the table in the formula. F 3.75 is equal to 0.225 20.225. So 20.225 plus 0.5 మనం తీసుకున్నాం 0.5 plus minus 1.58 ఇక్కడ ఉంది minus 1.58 then 0.5 0.5 minus 1 u into u minus 1 కాబట్టి by 2 factorial into 0.327 u plus 1 అంటే 0.5 plus 1 u అంటే 0.5 u minus 1 అంటే 0.5 minus 1 by 6 that is minus 0.338. U plus 1, 0.8, u, u minus 1, u minus 2.1, that is by 24.009. Again, I am taking here 0.5 plus 2, u plus 2, u plus 1, 0.5 plus 1, u minus 1, u minus 2 by 24.5 and the values in the values minus 0.003. So we are writing these values here, we are taking that one. So these are the values I am taking the sun substituting here 20.225. 0.5 minus 1.551, 0.551 this is a 0.5 by 2, 0.5 into minus 0.5 by 2 into 0.237, 0.5 under 2.5, 1.5. So 0.5 until minus 1.5 వస్తుంది ఇక్కడ 1.5 this is 0.5 minus 0.5 by 6 minus 0.833. Then 0.5 plus 1.5, 0.5 minus 0.5, 1.5. ఇక్కడ minus 1.5 0.009. This is 2 plus 0.5, 1.5. Then 1 minus 0.5, 0.5. This is minus 1.5 by 120. I'm multiplicating all these values here. 20.225 minus 0.705 and 0.046. you can take in the 19.4075. Yeah, taking here. Then immediately, so they immediately are using Gauss backward interpolation formula. Find the population of the city in Lab during 1996 by interpolation data given here and 1941, 1951, 1961, 71, 81, 91, 2001, 12, 15, 20, 27, 13, 52, 70. So H is equal to 90. Find 1960 taking the origin x naught is equal to 1971. 1966 and x minus x naught by h. 1966 minus 1971. Why? Because 1966 we are taking here. We are asked in 1966. 1966 minus 1971 by 10 is 5 by 10 is equal to minus 0.5. Minus 1 less than minus 1 less than 0. We apply Gauss backward interpolation formula. We are taking that y u is equal to y naught plus u delta y minus 1. U plus 1 u by 2 factorial delta square y minus 1. U plus 1 u minus 1 3 factorial delta y minus 2. U plus 2 u plus 1 u minus 1 by 4 factorial delta y minus 2. U plus 2 u plus 1 u into u minus 1 u minus 2. We are taking 5 factorial delta y minus 3. U plus 3 u plus 1 u into u minus 1 u minus 2 6 factorial. And so on the values I'm taking. And this one 1941, 1951, 1961, 1971, 1981, 1981, 2001 I'm taking here. That is 12, 15, 20, 27, 20, 13, 50 to 70. That is here. So I'm taking the center of the value that is 3, 3 gone here. So 1961. So 1971 I'm taking 0, 3, 3 gone. 1971 is the center point. Minus 3, minus 2, minus 1, 0, 1, 2, 3. So so taking the values here. 12, 15, 20, 27 to 13 and 50 to 70. So I'm taking here this one. So 15 minus 12, 3, 20 minus 15, 5, 27 minus 27, 39 minus 27, 12, 52 minus 13, 13, 70 minus 52, 18, 5 minus 2, 7 minus 5, 2, 12 minus 7, 5, 13 minus 12, 1, 18 minus 35, 2 minus 2, 0, 5 minus 2, 3, 1 minus 5 minus 4, 5 minus 1, 3 minus 0, 3, minus 4 minus 3 minus 7, 4 plus 4 is minus 7 minus 3 minus 10, 8 plus 7, 15, 10 plus 15, 25. There is only one value, so we did not process the next step. We did not process the next step from the above table. That is why del y, del square y, del 2 by, del 4 by, del 5 by, and del power 6 by. So therefore, we are taking here. So the substituting the relevant values from the table of the formula 1966 is equal 27. 27 వచ్చింది ఇక్కడ. So 27 I am taking here. Then minus 0.5. So that is the value here. Minus 0.5 plus 7. What is 7 here? We have to state here minus 0.5. Minus 0.5 here. This is the one. So 51 interval is staying here. U plus 1. So u of delta y minus 1. Delta y minus 1 that is delta y minus 1 that is 7, 5. So 27 అట్లా తీసుకుంటాం 27 12 అట్లా తీసుకుంటాం ఇక్కడ. So see here 27 plus minus 5 0.07 plus 0.1 plus 1 that is 5. 5 వస్తుంది ఇక్కడ 7 5 3 3 తర్వాత 7 10 minus 7 వస్తుంది. So 0.5 minus 0.5 plus 1 into minus 0.5 minus u plus 1 minus u minus u minus. So that is our u minus 2. We are taking the values here. U plus 1 into u into u minus 1. What is the values I am taking here? With the basic fundamental of formula. 0.5 plus 2 minus 0.5 plus 1 minus 0.5 minus 0.5 minus 1 by 24 of minus 7. Minus 0.5 plus 2 minus 0.5 plus 1 minus 0.5 minus 0.5 minus 1 minus 0.5 minus 2 by 122 minus 10. Minus 0.5 plus 3 minus 0.5 plus 2 minus 0.5 plus 1 into minus 0.5 minus 0.5 minus 1 minus 0.5 plus 2 by 720 into 25 I am taking here. 27 plus minus 0.5. So I am simplifying this equation. So f of 1966 equal to 22.8935. So this is the one. What is the Stabile interpolation? So Stabile interpolation formula, experience with doing interpolation using center differences the Gauss formulae are not much practical use. However, we observe that there are several steps important formula due to Stirling and these Bessel. We now obtain the Stirling formula by taking Gauss forward and Gauss back. Consider the Gauss forward interpolation formula. Y is equal to y naught plus u delta y naught into u minus 1 by 2 factor u square y minus 1. So ఇక్కడ y naught yb is equal to y naught plus u delta y naught into u minus 1 by 2 factor del square y minus 1 u plus 1 into u minus 1 by 3 factor del cube y minus 1 u plus 1 u minus 1 u minus 2 by 4 factor del 4 y minus 2 and so on 1. By the Gauss backward interpolation formula y naught plus u into delta y minus 1 u plus 1 u by 2 factor by del square y minus 1 u plus 1 into u minus 1 by 3 factorial by del cube y minus 2 u plus 2 u plus 1 u minus 1 by 4 factorial by del 4 y minus 2 I am taking here. So therefore, taking the mean of the two formulas running to this y naught plus u del y naught del minus 1 by 2 plus u square del 2 factorial del square y minus 1 u into u square 1 by 3 factorial. This is del y minus 1 del y naught is the del y minus 1. This is the one function just in formula. U into u square minus 1 by 3 factor del cube del cube y minus 1 plus del cube y minus 2 by 2 plus u square into u square minus 1 by 4 factorial del 4y minus 2. The formula is called as Stirling interpolation formula. In the Stirling interpolation formula, observe that is taking into all the averages, all or differences like this. We are taking here from the central line, we are taking here y naught is equal to del y minus 1 by del y naught. So these the two values simplify del square y minus 1, then del y minus 2, del y minus 1, then del 4 minus 1, these two simplification values, then del 5 y minus 3, del 5 y minus 2 simplification value, del 4 6 y minus 3, we are taking that values here. So this is the formula for interpolating the values mean minus 1 by 2. Minus 1 by 2 less than u minus 1 by 2, 0.5 less than u, 0.5. A good estimate will be obtained minus 1 by 4 less than u less than 1 by 4. So apply Stirling interpolation formula, find F28 following the data we are taking here. So 20, 49, 225, 25, 48, 316, 30, 47, 236, 35, 45, 96, 40, 44, 306. Equal 5. Find F28 with the odd x naught is equal to 30. X is equal to 28 I am taking here. So x naught is equal to what is the value asking is equal x naught is equal to 28. X minus x naught by h, that is 28 minus 30 by 5. 28 minus 30, and we are taking this as a center value by 2 by 5 is equal to 0.4. So we are taking that is a, since minus 0.5 less than u less than 0.5, we are applying the Stirling's formula, we are taking here only y u is equal to y naught plus u del y naught plus del y minus 1 by 2 plus u square by 2 factorial del square y minus 1 u square minus 1 by 3 factorial del cube y minus 1 plus del cube y minus 2 by 2 factorial u square into u square minus 1 by 4 factorial del power 4 by taking here. We now consider the central difference table to the given data we are taking here. 20, 25, 30, 35, 40, minus 2, minus 1, 0, 1, 2. So x minus 30. So we are taking here 30 minus 30 by 5 minus 2. 25 minus 30 and 1, 30 minus 30, 0, 35 minus 1, 2. So what is the values we are taking here in the center difference table? So to 49, 2, 20, 48, 3, 1, 6, 47, 2, 36, 45 minus 44, 3, 0, 6 we are taking here. So I am taking 48, 3, 1, 6 minus 49, 25 minus 1, 9, 9, 47, 2, 36 minus 48, 3, 1, 6, 10, 80. Then 45, 926 to 47, 236 minus 31, 0, 44, 326 minus 45, 90 minus 16, 20. These four values minus 1890 plus 909. So these are the minus value is high, therefore minus 9. Minus 3110 plus 1080 minus 210. Minus 620 plus 1320 minus 10. So minus 230 plus 271. Minus 230 minus 59. Minus 230 plus 230 minus 80. Minus 80 plus 59 minus 21. The values is breaking here from the between the values here. So now substituting the relevant values from the table of the Stirling formula. Y minus 4, therefore 25, 4, 7, 2, 3, 6. They are writing here minus 0.4, minus 13, then minus 1080 by 2, plus 0.4 whole square, minus 230. So my plus minus 0.4, minus 0.24 whole square, we are taking the values here from the table. So what is the value now? Minus 0.4 here. Minus 0.4, minus 0.4 square, 1 by 6. Minus 80, minus 15 by 2, minus 0.0 square, minus 0.0 square, 1 by 24, minus 21. So these values are approximately, I am taking these values here. That is F28, 47, 621.8256. The Bessel interpolation. What is the Bessel interpolation? The Gauss forward interpolation formula is given by y is equal to y naught plus u delta y naught u to u minus 1 by 2 factorial del square y minus 1 u plus 1 u minus 1 by 3 factorial del cube y minus 1 u plus 1 u minus 1 u minus 2 by 4 factorial del power 4 y minus 2. I am taking here. So therefore, del y naught is equal to y1 minus y naught. Y naught is equal to y1 minus del y naught. So y1 minus del y naught. Y naught akkade untundi. It is equal to y1 minus del naught. Y minus 1 is equal to y naught plus del y minus 1. Automatically, del square y minus 1 is equal to del square y naught minus del cube. It is a delta. Applying the del 4 y minus 2 equal to del 4 y minus 1 del 4 y minus 2. So this is the rewriting of this formula here. y naught is equal to y naught by 2 plus y naught by 2. U delta y naught is equal to 1 by 2 into u minus 1 by 2 factorial del square y minus 1. 1 by 2 into u into u minus 1 by 2 factorial del square y minus 1. U plus 1 into u minus 1 by 3 factorial del cube y minus 1. And 1 by 2 into u plus 1 into u minus 1 by u minus 2 by 4 factorial del forward y minus 2. 1 by 2 into u plus 1 into u minus 1 by u minus 2 by 4 factorial del power 4 y minus 2. And using 2, 3, 4, these 2, 3 formulas. What is 2 y naught is equal to y1 minus delta y naught, del square y1 del 4 y minus 2. These values are I am taking applying here. Y u is equal to y naught by 2 plus 1 by 2 y1 minus delta del y naught. U delta y naught is equal to 1 by 2 plus into u minus 1 by 2 factorial del square y minus 1. Then 1 by 2 into u minus 1 by 2 factorial del square y naught minus del cube y minus 1. U plus 1 into u minus 1 by 3 factorial del cube y minus 1. On by 2 into u minus 1 by 2 factorial del square minus 1 del cube by minus 1. So therefore, we are taking here u plus 1 into u minus 1 by 3 factorial del cube by minus 1. 1 by 2 u plus 1 into u minus 1 by u minus 2 factorial del power 4 y minus 2. So 1 by 2 into u plus 1 u minus 1 by u minus 2 by 4 factorial del power y 1 by del power 4 y minus 1 plus del power 5 y minus 2. So therefore, y0 plus y1 by 2 by u minus 1 by 2 del y naught. Then 1 by 2 into u minus 1 by 2 factor del square y minus 1 del square y naught into u minus 1 by 2 factor minus 1 by 2 plus u plus 1 by 3 factor del cube y minus 1. 1 by 2 u plus 1 into u minus 1 u minus 2 by 4 factorial del power 4 y minus 2 plus del power 4 y minus 1. So y is equal to y naught plus y1 by 2 u minus 1 by 2 del y naught into u minus 1 by 2 factorial del square y minus 1 del square y naught by 2 u minus 1 by 2 into u minus 1 by 3 factor del cube y minus 1. U plus 1 into u minus 1 u minus 2 by 4 factorial del power 4 y minus 2 plus del power 4 y minus 1 by 2. And what we are taking y0 plus y1 by 2 we are taking u minus 1 by 2 taking u into u minus 1 by 2 factorial. So all the del square y minus 1 del square y not taking and del cube y minus 1 taking. Just therefore y minus 2 plus del 4 y minus 1 by 2. So this is the Bessel interpolation formula. So observe these Bessel interpolation, all the orders are different slides between center line and the edges. The central different line like y0 y1 is delta y0 delta square y1 del square by delta cube y1. So del 4 y minus to del 4 y minus 1. This formula is usually interpolating these values only 0 less than u less than 1. Accurate results 1 by 4 less than u less than 3 by 4. 0.25 less than or equal to u less than or equal to 0.75. I am taking these values. This one is one example we are taking here. So one example we are taking here. So what is the example? Apply the Bessel interpolation formula F25 given that f of 20, 2854, 20, 2854, F24 is equal to 3162, F28 3544, F32 is equal to 3992. So what I am taking here x is equal to 5 f of 25 and find the origin x0 is equal to 24. So x0 is equal to 24. Why? Because often 25 we are taking here, but 20, 24, 28, 32, the four values is given. So 25 we are taking x0 is equal to 24. 25 minus 24 is equal to 1 by 4 is equal to 25. The ordinate 24, 25 is right? Hence we can actually apply Gauss forward interpolation formula 0.25 and 0.25 points on the Bessel information formula back currency for the result. Y0 plus y1 by 2, that is u minus 1 by 2 we are taking here. Delta y naught u minus 1 by 2 by 2 del square y minus 1 plus del square y naught by 2 u minus 1 by 2 but u into u minus 1 by 3 factor del cube y minus 1. Now we construct the central difference table. So 24 0 తీసుకున్నాం కాబట్టి minus 1. So 20 minus 24 by 5 minus 1 0 1 2. So what the values I am written here the same 28 54 these are values given 28 54 20 31 6 35 44 39 92. See here 31 62 minus 28 54 308. So 35 54 minus 31 62 382. 39 92 minus 35 54 448. 382 minus 398 74. 448 minus 390 62 66 minus 74 minus 8 we are taking the values here only. So now substituting these relevant values from the table of the Bessel's formula Find f of 25 3162 plus 3 3162 plus 3544 0 కాబట్టి రెండు వాల్యూస్ కలుపుతున్నాం మనం. సో అందుకే బోల్డ్ లెటర్ రాసాం. we are writing the bold 3162 plus 35442 plus 0.25 minus 1 by 2 into 382. ఇక్కడ చూడండి 382 into 0.25 74 plus 66 by 2. Then 0.25 minus 1 by 2 u minus 1 by 2 u minus 1 it by 6 into minus 8. We are taking these values here. So this is simplification I am doing here. 353 95.5 9 minus 9 6.565 0.0625. The total is 3250.875. Then Laplace average interpolation formula. Cross forward interpolation formula. Cross forward interpolation formula is given by y naught u delta y naught u to u minus 1 by 2 factor del square y minus 1 u plus 1 u minus 1 by 3 factor del cube y minus 1 u plus 1 u minus 1 u minus 2 by 4 factor del power 4 y minus 2 u plus 2 u plus 1 u minus 1 u minus 2 by 5 factor del 5 del power 5 y minus 2 we are taking here. So del y naught is equal to y1 minus y naught del cube y minus 1 equal to del square y naught minus del square y minus 1 del 5 y minus 2 equal del power 4 y minus 1 minus del power 4 y minus 2. Substituting these order difference in cross forward interpolation formula, y is equal to y naught plus u into y1 minus y naught, then u into u minus 2 factorial. అంటే అక్కడ ఏం చేస్తుంది u u minus 1 del square y minus 1 తర్వాత u plus 1 u minus 1 del square y naught minus del square minus 1 u plus 1 తీసుకుంటాం బట్ ఇక్కడ u minus 2 యాడ్ అవుతుంది u into u minus 1 u minus 2 del 4 y minus 2 u plus 2 u plus 1 u into u minus 1 u minus 2 del 4 అంటే ఇక్కడ రెండు తీసుకుంటాం ఇక్కడ ఒక u minus 2 అనేది del 4 y minus 2 ఇక్కడ u plus 2 u minus 2 తీసుకుంటే del 4 y minus 1 and del 4 y minus 2 y minus 1 minus 2. So that place of so on we are taking here 1 minus u plus we are simplifying here 1 plus 1 minus u y naught u into u minus 1 by 2 factorial u plus 1 by 3 for del square y minus 1 u plus 1 u into u minus 1 by 3 factorial del square y naught 1 u plus 1 u into u minus 1 u minus 2 1 by 4 factorial minus u naught u plus 2 by 5 factorial del power 4 y minus 2 u plus 2 u plus 1 u into u minus 1 u minus 2 by 5 factorial del power 4 y minus 1. So 1 minus u y naught minus u into u minus 1 u minus 2 by 3 factorial del square y minus 1 u plus 1 u minus 1 by 3 factorial del square y naught. So this is a simplification what we are doing here minus u plus 1 u into u minus 1 u minus 2 u minus 2 by 5 factorial del power 4 y minus 2 u plus 2 u plus 1 u into u minus 1 u minus 2 by 5 factorial del power 4 y minus 1. To get a convenience from the formula 1 minus u is equal to u is equal to 1 minus u and changing the terms the negative sign v y naught is equal to v into v square 1 by 3 factorial del square y minus 1 v into v square minus 1 square v square minus 2 square by 5 factorial del 4 y minus 2 plus and so on వస్తుంది ఇక్కడ u into 1 v cube minus 1 cube v cube by v cube minus 3 cube by 6 factorial del power 6 y minus 3 వస్తుంది u minus 1 u by 1 u into u square minus 1 square by 3 factorial del square y naught u into u square minus 1 square into u square minus 2 square by 5 factorial del 4 y minus 1. This is known the formula of Laplace average interpolation formula here. So in the central line what we are taking here y0 y1 y0 del square y minus 1 del 4 y minus 2 y1 del square y naught del 4 y minus 1. This formula is used for interpolating the value of u like between 0 and 1. Accurate results of the option 1 by 4 less than u less than 30 0.5 less than or equal to u less than or equal to 0.75. This is the relation between the Bessel's formula and the average formula and can be deducted from the other suitable rearrangements. Bessel formula is truncated, the third order difference is the same average formula truncated of the second order differences here. There is one problem we will have. One problem we are taking here using Laplace average formula find log 337.5. 337 means is nearby, these values are given here. 337.5, 330. I already told 330 is nearby, 337 minus 330 by total 10. If the interval is 10, 330 minus 320, the interval is still taking here. H is equal to 337.5, the nearby is equal to 330. Since u is equal to 0.75 lines 0.25, 0.75, we apply Laplace average formula, obtain better accuracy of the result. Laplace average formula yu is equal to v by naught plus v into v square minus 1 square by 3 factorial del square y minus 1 v into v square minus 1 square v square minus 2 square by 5 factorial del power 4 y minus 2 u by 1 into u square minus 1 square by 3 factorial del square y naught u into u square minus 1 square v into square minus 2 square by 5 factorial. The values are expanding del 4 y minus 1. So what is 1 minus u? 0.1 minus means it is 0.75 we are taking here 0.75, that is 0.25. So 330, we are taking 330 is a zero value here. So 330 is zero value, 320 minus 310 minus 330 and minus 2, 320 by 330 is 1, so 330 0, 340 into 1, 350 into 2, 360 into 3. So I'm taking the values of y values I'm writing here as usually. Y values I'm writing here 2.491. I'm writing here 2.50 by 2.5 0.014, 2.18, 2.50 by 0.0013, 2.53 2.18 0.013, 2.544 2.530 0.013, 2.566 2.55 for 0.112. So 0.01013 minus 1 0.1, 0.13 is a 0, ఈ రెండు is a 0, ఈ రెండు minus 0.1. ఇందులో నుంచి తీసేసే 0.001 plus 0.11, 0 minus 0, this is minus 0.01. So minus 0 minus 0.01 minus 0.01. ఈ రెండు తీసి plus or minus the value is 0 I am taking here. So at 3.30 at 1.5, the values I'm substituting here 0.25 and 2.15. See here 2.158 and 0.25, 0.25, 1.4 square is equal to 0, 0. Then 0.25 to minus 0.11. These values I am simplifying. I am applying these values. That is F3 that is on 2.5728. Log 337.5 is equal to 2.5278. This is approximately. So in this unit, we can learn that the several interpolation formula, Gauss, Stirling, Bessel, Laplace, several formula by making interpolation here in the middle of the tabulation values here. All these formulas help to calculate the desired x from the tabulated data equal spacing. The coefficient of the central difference formula are smaller and coverage faster than the in Newton's formula. After a few terms, the coefficient of the Stirling formula decreases more rapidly than those of the Bessel's formula, and the coefficient of the Bessel formula decreases more rapidly than the Newton formula. As such, whenever you have to interpolate the point in near central part of the table, Bessel formula is Stirling formula, average formula of interpolation, minus 1/4 to 1/4, preferred Stirling formula here lies between 1/4, 3/4, the average form. Any doubts, ask me. Tomorrow we'll give 17.